So you're going to write the conditional. You're going to write the converse, the inverse, the contrapositive, and the biconditional. All right, so write that, and then we'll do it together. Oops. If you have a triangle, then their angles sum to 180.
So you can like rewrite it to make it make sense then?
The converse, just switch them. If angles sum to 180, then you have a triangle. All right, now remember these two, you just rewrite the thing again and negate everything. If it's already negated, then you make it positive. All right, so the first one is, if you don't have a triangle, then you don't have to say it like this. The interior angles don't sum to 180. Okay? Then you say if angles don't sum to 180, then you don't have a triangle. Biconditional. You have a triangle if and only if their interior angles, you don't have to have the interior part, sum to 180. Who got them all right without anybody helping them? Oh, wow, that's awesome. Awesome. All right, let's go on to the next one. Okay, write the next three terms of the arithmetic sequence or arithmetic sequence. Okay, so it's going by threes. So 14, or adding 3, I should say. 14, 17, 20. All right, did you actually add correctly? Nobody's going to admit that they missed it. All right, go to the next one. Counterexample. Prove it wrong, please. So if n equals 6, then n squared is 36. And is 36 always less than 6? Okay, so that's not true. How about a different number? So you got to prove it wrong. Give me an example where it's not true. So it said rational on purpose, so probably try a fraction. How about 1/2? And squared would be, what's 1/2 squared? Digging. 1/4? 1/2 times 1/2 is 1/4? Right? Is 1/4 less than 1/2?
Yeah.
Right. So n squared is always less than n if you're dealing with fractions. Okay? So 36 is not less than 6, so that was a good example. But what I want you to do is when you start to see these weird names that they give you, make sure you're trying the weird numbers. All right? And then all you have to do is find the one that's wrong. All right, so I just wanted to point all that stuff out to you. All right, next. Law of detachment. Sorry, it's a little blurry. So all you have to do is look at the hypothesis. If a triangle has equal side lengths, and then look at what they gave you. Triangle ABC has equal side lengths. If those are saying the same thing, then this is a true possible statement. That's all you got to say. means the conclusion has to be true. And then you can read it. You don't have to read the conclusion. Okay? So you could say, by the law of detachment, which you're not going to do it on this problem because it's telling you to use the law of detachment. By the law of detachment, triangle ABC has 60 degrees for each interior angle. And the law of syllogism to figure this out, if it's a true statement. So, is it true? If it does not rain, then I'll walk to school. There's nothing wrong with that statement. If I walk to school, then I'll wear my sneakers. Okay, that could be a true statement. Okay, so the third statement should be you identify the two things that are equal, okay, and write the other two things. So you're going to write, if it does not rain, then I'll wear my sneakers. That's what you should have written. Who wrote that? Awesome. What'd you get?
Line point postulate.
Line point postulate. Were you given a line?
On the second one.
No, that's your conclusion. Whoops. This is what you've been given. So remember what I said. It's always look at what you've been given. Yes. 3-point postulate. Who has the 3-point postulate? There exists exactly one line that's collinear, right? Contains the points. Got it? All right. Okay. Can you assume the statement that A, B, and C are coplanar? Can you conclude that they are coplanar? A, B, C. All right, everybody. Let's go through these. Can you assume that line CD is perpendicular to plane P? Do you see a 90-degree mark? Is there anything else that would say that they are 90 degrees? Then you cannot assume it. Let this be your first lesson on assumption. You have to have a factual piece of information saying what it is you're saying, proving what you're saying. You're saying they're perpendicular, but there's nothing in that diagram that shows 90 degrees of any sort, which is what perpendicular means, okay? So you cannot assume CD is perpendicular. Number 2, points A, B, and C, A, B, and C are coplanar. Can you assume that? This is not a trick question. Yes or no? Who says yes? A, B, and C, are they in the same plane? Yes. Yes. Number 3, planes M and P, both of those planes, they intersect at line FH. Is that true? Can you assume that? Yeah, so we say we can never assume something. What that means is, can you say it without a doubt, meaning you have the information proving that you can. So yes, that line is the proof. And then line DJ intersects FG at point G. Does line DJ, can you assume that it's going to intersect FG at G? So let me point it out. Here's DJ, and FG is right here. Can you assume it? No, you cannot assume it. It doesn't show it. And even if you drew a line through there, how do you know you drew it exactly correctly? All right, so you cannot assume that. All right. All right. This is 2.1. Let's go ahead and add a picture here. All right, let's go with okay, so I want you to write the conditional statement, the converse, the inverse, the contrapositive, and the biconditional. Begin. All right, so we said conditional statement, if you have two right angles, then they are supplementary. Okay, converse, you just switch it. If you have supplementary angles, then they are right angles, which obviously is not totally true, but you're just rewriting it, okay? We're not worried about true or false yet. The inverse and the contrapositive means you rewrite those first two and negate them. If they're already negated, then you make them positive. All right? So if you don't have two right angles, then they are not supplementary, which also is false. You can have 120 degrees and 60 degrees. Those are supplementary and they're not right angles. So again, we're not worried about true or false right now. And then the contrapositive, take the converse and negate it. If you do not have supplementary angles, then they are not right angles. And then the biconditional. Two angles are right angles if and only if they are supplementary angles. All right, number 2. All right, give me the next 3 pieces of the pattern, please. So add 2 to 0, and then you added 4, and then you added 6, and then you added 8. So you're going to add 10 to get to 30. You're going to add 12 to get to 42. And you're going to add 14 to get to 56. So 2, 4, 6, 8, 10, 12, and 14. That's how you're adding it going forward. A line S divides segment MN into 2 line segments. So the line S is a segment bisector of MN. All right. Find a counterexample, please. Draw a picture. Show me a counterexample. This is your conclusion, and there's nothing in the first part that says you have a bisector. All right, so line S, and we can say segment MN. That is definitely not a bisector. All right, so if you were to draw it correctly with hash marks, that's how you could say. I mean, visually they're not equal. We good? Yes? Okay. All right. All right, use the law of detachment, just like it says in the instructions. To determine what you can conclude from the given information if possible. All right, so do you know the law of detachment? Begin. You have to have what they're telling you match your hypothesis, and they do not match. So you can't conclude that they actually had a healthy breakfast, and therefore that they're not hungry until lunchtime. You can't say that that's based on them having a healthy breakfast. So what they should have done for this to be a true conclusion, this was your conclusion right here, is that the second part that they gave you, that should have said you ate a healthy breakfast. The yellow. The very last statement. Oh, the conclusion is right there. Remember, you have to identify hypothesis and conclusion. So the very first thing is your conditional statement. And the hypothesis has to match the last statement they gave you. You are not hungry at lunchtime. That does not match your hypothesis. So you can't conclude what they're saying. If it were to say, you ate a healthy breakfast, then you would say, we can conclude that you will not be hungry at lunchtime. That's what you would say. If it doesn't match the hypothesis, you need to say, no conclusion, or not true. I'd prefer you to say, no conclusion. So, use the law of syllogism to write a new conditional statement that follows the pair of true statements. Begin. Guys, I can't make it much easier if you could just remember what I told you. Identify the two pieces that are exactly the same. So if a polygon has three sides, then it is a triangle. If a triangle has two congruent sides, then it is an isosceles triangle. Okay? So, is it possible? Is there anything up there that's identical? No. Okay, so let's look at another one. Let me see if I can find a good one here. Okay, here we go. Let's put another one on here. So, don't always be looking for something that is going to work, but that's kind of what you've been ingrained to look at. Let's take a look at number 9 here. Okay, number 9. Start with that and rewrite the third statement. All right, so what you should be visualizing here is that you have mowing the grass. Those two are identical. If you just cross those out and rewrite everything else, if it is Tuesday, then you water the flowers. All right, who actually got that right? All right, so make sure you can do that on the test. And let's do another one. Inductive or deductive reasoning. All right, so if having hair is a rule, then you're going to say that that's deductive reasoning. So what you have to ask yourself on the quiz and test, if you're asked this, is whether or not this is a rule or a fact or a law. That's what you have to answer. And then you say whether it's inductive or deductive. All right. Okay. Give me an example of a two-point postulate. Aha. Give me an example of a 2-point postulate. JH, or excuse me, IH. I could have said JH too. So you have to identify what the 2-point postulate is. What's given in a 2-point postulate? That you have 2 points. So just pick any 2 points in the same plane, preferably. So I and H are in the same plane. And then you could say, the 2-point postulate tells me that there has to be a line that goes through them. Technically speaking, you could say CJ or JG, but really that would be the line point postulate, because you see a line and then you know there's at least 2 points that are on that line. Understand why you pick which one's which?
So J and H are a 2-point postulate.
JH, since there's no line visible, you could say, well, I know there's a line there because of the 2-point postulate. And if you chose like CJ, then you would need to say, hey, that's a line point postulate. Because I see a line, I know there's at least 2 points on it. Okay? You got to know this so you can say things. You say, well, I know there's a line there. Even though I don't see the line between I and H, I know there's a line there. Well, prove it. I'm going to tell you to prove it a lot. And you would say the 2-point postulate.
You have to know this for the quiz, right?
You have to know all the postulates for the quiz. It'll be easier on the quiz. On the test, stuff like this. You understand? All right, line intersection postulate. Line intersection postulate. Oops, sorry. 2 lines that intersect, that would be CG and EJ. You could use some different letters on those lines, but those 2 intersect. 3-point postulate. D, I, and H, given 3 points, non-collinear points, then there must be a plane that goes through them, and that would be plane A. Oops, I'm sorry, I put that in the wrong spot. That's the 3-point postulate. And that's the line intersection postulate. How about the plane intersection postulate? What would you tell me? Plane intersection postulate. Plane A, plane B, at CG. All right, so to start this, I'm giving you a conditional statement. Tomorrow you'll actually have to write the conditional based on information. So what I want you to do is write the converse, the inverse, the contrapositive, and the biconditional. So write that statement down quickly because I'm going to take it off the screen. All right, so you say if an animal, is a mammal, then it is a bear. Who got that far? If an animal, is a mammal, then it is a bear. That's what that says. That's the converse. Now, the inverse and the contrapositive are the negation of the first two. So you would say, if an animal is not a bear, then it is not a mammal. You got that right? All right. And the contrapositive, if an animal is not a mammal, then it is not a bear. You have to do this on the quiz tomorrow.
You have to do it just like once.
All these. So, one thing, you're going to write all 5 statements. Okay, biconditional. An animal is a bear. Class.
If it's a mammal.
If and only if it is a mammal. So it's not about being true or false here. We're just saying, do you know how to write these? Don't screw these up tomorrow.
Can you go over one where we actually make it conditional?
Sure, let me give you one. Just a second. Okay, so here's one for you. Let me just move all this up here. Here's an example. A fish lives in water. Make that a conditional statement, please. If a fish lives, then it is in water. So that would be your conditional statement. All right. Please draw the next picture. Just for the sake of getting it done quickly. You have 1 there, 2 there, 3 there, so this needs 4. 1, 2, 3, and 4. And yeah, when you're drawing it, draw a little nicer, but I just need to see that you understood you needed 4 rings on that cobweb. How's it going to be worded? If I were to give this question, I would say draw the next picture in the sequence. All right? The easy part about this is you actually don't have to say what the angle measures are. You could, but if you drew vertical angles and made them 90 degrees, first of all, at an intersection of 2 lines, if you have 90 degrees, they're all 90 degrees. Okay, so that means this is 90 and that's 90. Well, complementary means that you have 2 angles and only 2 angles that add up to 90. Right off the bat, that's false. Because these 2 add up to 180. But you wouldn't have to do it. I mean, you could draw something like this and say, this is 80 and this is 80. Well, that's 160. Okay, still not 90 degrees. So the only way for 2 vertical angles to be complementary is if you had 45 and 45. You can't have 2 vertical angles being complementary if they're at any other degree. Does that make sense? So that was a thinking problem. All right, let's move on. Law of detachment. So let's find out who remembers law of detachment. So you need to use the law of detachment to see if you can conclude, if possible, that this is true. The first part should say, if you have adjacent angles, then they share a common ray. The law of detachment, all you have to do is identify the hypothesis. In this case, your hypothesis is if you have adjacent angles. And then you have to look at what they gave you. All right, so since they gave you those angles, you should understand whether or not those are adjacent. They say they're adjacent. What they tell you, you're supposed to assume is true. But even if you drew that, okay, you have AOB, A, O, and B. And then you have DOB. Okay, so B is already on there, so B to O to D. Okay, it doesn't have to be a straight line. Let me just make it different. Okay, it could be D, O, and B, D right here. Okay, so based on what they gave you as a statement, this picture is that statement. You didn't have to draw it, but you should have understood that they had a shared ray. OB is their shared ray. All right, so because this statement matches your hypothesis, and that's all you have to check, then you say, yes, the conclusion is true. Remember, you have a hypothesis and a conclusion. The conclusion is they share a common ray. By the law of detachment, they share a common ray. Doesn't matter what it says. If the hypothesis matches the statement they give you, that's all you got to look at first. And then you can say the conclusion is true. If they do not match, you say, not possible. It doesn't matter if it even makes sense. You say it's not possible, or not true, or no conclusion. But all you have to do is look to see if those match. Yes?
So if we see like it's not true or it's true, do we have to put a reason behind it?
If you're saying it's true, then you say the conclusion. Okay?
But if it's not, then you
Just say it's no conclusion.
okay.
Law of syllogism. Write the third statement. Okay, so you identify the two things that are the same. You'll pass the class, you'll pass the exam. No, that's not right. If you pass the exam, you pass the exam. Those two things are the same. I said that's what you have to mark out. So then you say, if you study, then you'll pass the class.
If you study, you will find your class.
Okay? Who had that right?
I did.
Okay.
You did, shut up.
All right, write the next two, actually the next three in the pattern, please. Why?
Okay, I got the X and D right. I didn't get the W right. I put.
Okay. Is this inductive? Keep it to yourself. Or deductive? Circle or write down what you think it is. Inductive or deductive? You should have asked, is it a rule? Is it a fact? Is it a law? Or is this an observation or a pattern?
It's a bloody fact.
It's not.
It would be an observation.
It is an observation.
It's an observation, so you would say,
What?
whoops, inductive.
Well, I know what Walker School is.
Inductive is based on observations or patterns.
Oh, we were circling
Wait.
which one was right.
How is it not a
I
fact?
thought we were praying.
Because he doesn't.
It's not a fact or a law or a rule that you walk to school.
Oh, okay. Listen.
Wait, what
All right.
does deductive mean then?
Deductive means it's oh, it doesn't mean it's like an observation then. Like
All right. Number 9. Can you assume the statement? So number 9 says planes W and V intersect at line TU. Planes W and V intersect at line TU. Yes or no? What postulate is that?
Maybe plain postulate.
Plane intersection postulate.
That's the one.
So it's false because when two planes intersect, they form a straight line. And your straight line is right there. That is not TU. Okay? All right, next one. Points T and U and R. T, U, and T, U, and R are coplanar. Yes or no?
Yes.
What's the postulate?
3-point postulate.
3-point postulate. Through any 3 points, there is a plane. So what are you given? You're given the 3 points, and then they say the conclusion that they're coplanar. It's extremely important you start to think of what you've been given. Okay? That tells you the postulate, and it's also going to tell you other things. So angle TZX. All right, so let's draw this up here. TZX. TZX. And angle UZY. UZY. Are vertical angles. Yes or no?
Yes.
Yes. Okay. Line TU lies in plane W. Line TU lies in plane W.
No.
Absolutely not. It lies in plain R.
Plane V.
Oh, wait, no.
Wait, how do you know if it's R or V?
Oops, wrong one.
There's a letter without a point.
Yes.
Yeah. Okay. All right. Okay. Here's what I want you to do. All right, a line segment has 2 endpoints. I want you to write the conditional statement, the converse, the inverse, the contrapositive, and the biconditional. All right, so your conditional. Oops. If there is a segment, line segment, whatever, however you wrote it, then it has 2 endpoints. Converse is switch it. If a line has 2 endpoints, then it is a segment. Is just rewrite both of those. They go together just like these 2 go together. But you negate those first 2. If they're already negated, then you make them positive. Okay, so the inverse goes with conditional. So you say if there is not a segment, or you can say if a line is not a segment, then it doesn't have 2 endpoints. and then the conditional and the converse go together. If a line doesn't have two endpoints, oops, then it is not a segment. Biconditional is a line is a segment if and only if it has two endpoints. Okay, find the counterexample to this statement. All prime numbers are odd. So there's your counterexample, 2. Its factors are 1 and 2. All right. Law of detachment. Number 3 and 4. Can you conclude? Yes or no? Is it possible? If it is possible, then restate the conclusion or give me the conclusion. So 3 is not possible because the statement that they give you has to match your hypothesis. Does it match your hypothesis? Then don't even look at the conclusion. You say not possible or no conclusion, okay? Now everybody do number 4. Right, true, the angle is acute, and here's why. Here's the statement, and then there's your hypothesis. It doesn't matter what the conclusion is until you're ready to say something. So if the statement matches the hypothesis, then you just restate what the conclusion says, but say that it's true. Okay? So yes, the angle measure is greater than 0 if an angle measures between 0 and 90. And then they tell you the angle is 36. Well, that's between 0 and 90. So that matches your hypothesis. It'll be a little easier than that on the quiz, okay? So it matches the hypothesis. So therefore, you can restate the conclusion. That's what you're looking for, to see if, first of all, if it's possible at all. All right, let's go on. Law of syllogism. So number 5, use the law of syllogism to write a new conditional statement that follows from the pair of true statements, if possible. So everybody look at number 5 and first decide if it's possible by the law of syllogism. Let me just remind you the easy thing first. So law of detachment, you know what to look for. Same thing with the law of syllogism. Which two things are identical? This hypothesis and this part of the conclusion. Scribble those out. What's left? If x is less than -1, then x squared is greater than 1. Okay, so again, identify the things that are the same, and typically it's these two that are the same. Beginning is to middle, middle is to the end. That's how it usually is. So then you cross those out and just write what's left. So number 6 is if a straight angle is bisected. Now think about it. What's a straight angle? 180. If you bisect that, bisection means 2 equal pieces, so that means they'd be 90 degrees each, which are right angles. Then it is a right angle. So who got it right? Ugh. Good for you guys. All right, last one. Which of the following statements cannot be assumed from the diagram? All right, so we'll just say number 1, 2, 3, and 4. All right, so number 1, everybody do number 1. Just say yes or no. Can it be assumed? Yes or no on your paper. So I can blow this up while you're answering. A, B, and C. Come on. A, B, and C. Are they coplanar? Say yes or no on your paper. So what postulate is that? The 3-point postulate. Given 3 points, there exists one plane that goes through those 3 points. And A, B, and C. B and C are in both of those planes. So A, B, and C would be in exactly the same one plane, okay, plane T. But that's the 3-point postulate. All right. So that's possible. We can assume that. What about T and S intersect BC? T and S. Plane T. So plane T and plane S, they intersect at line BC. Write on your paper, yes or no. Yes or no? Okay, what postulate is that? Plane intersection postulate.
Well, yeah.
All right. So far, we haven't found any that cannot be assumed. So let's try number 3. Lines AB and CD intersect. AB and CD. Where's AB? There's AB and CD. Do those intersect? That would be false. You cannot assume that they intersect. They're skewed lines. Okay? All right. Let's go back. So number 3 was the one that you can assume. Let's see if there's another one. Number 4. CBF. So CBF and CBA. CBF. Oh, what do you want me to use? Okay. CBF, and what was the other one? CBA. Let's use red for that one. Can you see red?
Yeah, it's good. It intersect.
And are they a linear pair?
Yes.
Yes, they're a linear pair. That's a straight line. Because of this little thing right here. Okay. Well, AB goes through F, so we know that's a straight line. So, yes, they're a linear pair.
I'm studying tonight.
All right. Any questions on those? All right, that's it. All done.